Okay, so a quicker video today. We're just going to go through all the little Algebra 2 prep topics that we covered in the last couple of weeks. Now there's a lot more to Algebra 2 than that, but if you can factor and know your polynomials, when you get to that part, it'll be second nature to you. So the first thing, polynomials, combining like terms. I made a 7-term mess here in pink, and we're going to try to combine it into a smaller polynomial with the terms that go together. So if you notice, how many x to the fourths do I have in this entire row? It looks like I only have this one, and there are no other x to the fourths. How many from the x to the third family? There's this one, x to the third, and this one. Notice how when I highlight it or circle it, whatever you choose to do, I'm including the sign because that goes with it. All right, now we have another family. Let's go x squared, x to the second power. Here's one, and here's one. And then any of them that are just plain old x, here's one, and that's it. And then is there any that are just constants, meaning just numbers without an x? Just that one. So then you just combine what you have. How many of these were there? There was just that. So 4x to the fourth. Okay. Then you look toward negative 3x cubed plus 2x cubed. So that would be negative x cubed. All right, and then you can cross those off. And then if you have x squared and minus x squared, anytime you have something minus itself, that totally goes away, right? It's 0. And then the last two terms don't combine with anything, so you just bring them down. Negative 12x plus 7. So answer the question on Edpuzzle, but your final answer would have been here. Now a real quick comparison of 3 of the most important exponent rules. And I used x to the 7th and the exponent of 4 each time just so you could see the difference in the 3. When you have the base being the same, meaning the base of both of those is x. X is the base. If the base is the same and you're multiplying, you keep the same base and add the exponents. So that one is x to the 11th. Likewise, if the base is the same and you're dividing, you keep the same base and you subtract the exponents. Now this one, the bottom one, there aren't 2 bases, there's just one. It's x to the 7th, and then that quantity is raised to the 4th. If you're going from a power to a higher power, then you multiply the exponents. So here you add them because they're at the same level and they have the same base. But if you're going to a higher, not a higher number, but if you're raising it again, 7th to the 4th power, then you multiply. So it would be x to the what? And lastly, we covered factoring. You always look for a what first. You always look for a greatest common factor first, because it might be a multi-step factoring problem, especially in Algebra 2. So here's 2 examples, they're separate. I'm going to do this one first. What goes into 18 and also goes into 50? They don't both have x's, so it's just going to be a number. Looks like the number 2. Nothing bigger than 2, I think, right? So I'm going to pull out a 2, which means I'm dividing them both by 2, right? And that leaves me with 9x squared minus 25. Now, you're not done because the 2 stays here, and now I have a difference of 2 squares. The square root of 9x squared goes here, and the square root of 25 goes here, in those 2 spots. One is plus and one is minus. And just like that on the second problem, you also have to take out the greatest common factor. So what goes into 3x squared, 12x, and 63? Turns out that it is my first instinct is a 3 because nothing else goes into 3. So it's going to be 3, which means I'm dividing them all by 3, which leaves me with x squared plus 4x, and that would be 21. Now, you might not be done here either, right? Are there factors of 21 that add or subtract to 4? Are there factors of 21 that add or subtract to 4? So negative 21 adding or subtracting to 4, 7 times 3, some combination of negative 7 and 3, or 3 and negative 7, whatever. So we're going to keep the 3. Now you figure out what goes here and what goes here. Good luck.